we go. Now we're live. All right, number 1. Okay, if I'm going to graph number 1, I'm just going to start with some graph paper. Today's date is 1/24/2022. So I've got 04, which is about there. 16, 29, 2, 4, 6, 8, 9, and 3, 13. It's not kind of off the graph. So it is kind of exponential. So it's really hard sometimes. I know the beginning amount. I know I start at 4, but the b, the base, can always be found, always, by the second term, the second number, divided by the first number. Can always, if you can't figure out what the rate is, it's always going to be the second number, which is 6 divided by 4, which is 1.5. Because sometimes it's really obvious. You can see we're doubling. Or sometimes it's really obvious. You can see it's half and half. But if it's not easy to find the rate, then you can always take, if you want to write this down, the second number divided by the first number will always give you the rate that's increasing, okay? So this always, yeah, if it's exponential, the second one divided by the first one will always give you the base. So my equation would be a y equals 4, because that's my beginning amount, times my rate, which is 1.5 to the x power, okay? Second number divided by the first number. Yep. Always. If it's exponential, Mars, always. If it's exponential, always. Okay? All right. Number 2. Am I going too fast? Okay, and if you didn't get a worksheet or review sheet, it's right here. Okay? If you're coming in. Tay, am I going too fast? You just got in, right? I'm going to slow down for a second. Okay. 10. So I don't really need to plug them in, but if I did, and I use my calculator, right, I'd just go 40 times 1/2 to the power of -1. And I get, I think, 80, right? So I've got an 80. And then if I plug in 0, I can go 40. 1/2 to the 0 gives me 40. And if I plug in 1, I get 20. And then obviously 10 and 5. I mean, that's just, right? That's pretty obvious. So if I graph it, then I'm just going to have it look like this. And definitely exponential decay, right? Definitely exponential decay. Now, domain is how wide are all the x values? Well, it's everything. I mean, this thing goes forever this way. And believe it or not, even though it's just going up and up and up and up, it's always moving over, isn't it? It's just way up there. It's always moving, right? So, these points here, so it's forever wide, all x values. So the domain, we're going to say all real numbers. So my domain is x equals all real numbers. My range is different because it never touches 0. So it's the y values. So my range is just going to be y is greater than 0. There's my range. Okay? Am I going too fast or am I okay? I'll slow down for a second. Okay. Number 3. If they have the same base, for this, what equals for this is really like saying x plus 3 is really equal to 5x plus 3. Okay? And so if you have the same base, you can just cross out the bases and solve. So if I solve, I can go minus x. I got a 3 equals 4x plus 3. right? Minus 3, minus 3. I'm running out of room, but I'll slide over here. 4x equals 0. And you know what? 0 is a number. 0 is a number. 0 can be an answer. Don't be afraid when you get an answer of 0. 0 is a number. X equals 0. Okay, all right. So 4 is different. We got to make it in the same base. And a long time ago, I gave you a chart of all of those numbers, right? And I, probably have them in my notes somewhere. But to make them the same number, I know this. 8 is 2 cubed. That's 8. And 32 is 2 to the 5th. 2 times 2 times 2 times 2 times 2. We have to make them the same base so that we can cross them off. If I looked at number 3, the way I solved 3, the way I did 3 was like, hey, same base, I cross them off, right? So I want to do the same thing here. 2 and 2, and I can cross them off. So the whole goal was to make them the same base. I'm not done yet, but I did make them the same base, right? So let's see here. Let's finish this problem up. So I'd have a 2 to the 3x and a 5 to an x plus 3. And then, since I have the same base, I can just cross out the bases. And you have a 3x equals a 5 times an x plus 3, right? And I'll just solve for x once you get caught up, okay? But the goal is, if once you make them the same base number, cross them off and go from there. Okay, so then I'll shoot my work up here because I'm running out of room. I'll have a 3x equals a 5x plus 15 because I just distributed. Oh, minus 5x, negative 2x equals 15. Divide by negative 2, and I think that's negative 7.5 if I divide by negative 2, okay? Okay, now 5 and 6 should be easy, especially after our Kahoot, right? We should be able to get that easy because we just got done doing this kind of problem in our Kahoot. We know we're going to start with 20,000. We have to have the 1. You have to have the 1 there. The 1 is very important. And we're gaining, we're earning money, so it's going to be plus. Plus, because it's going to be growing, plus my 0.03 to the x value, or t. I like t for time. X is okay, okay? Now the balance after 6 years, I'm just going to put 6. And for t, right? And use a calculator. I can't do this without a calculator. 20,000. 1.03 to the 6th power. And we're going to go clear. 20, 1, 2, 3. 1.03 to the 6th power, and I get about $23,881 and about 4 cents. Okay, thumbs up on that. Does that seem pretty easy? Okay, so if I put a problem like that on the test, which I will, put a problem just like that on the test, you can do that, right? Okay, 6. The only difference about 6 is it depreciates. So instead of plus, we'll put subtract. Okay, so I'll take, because most cars do depreciate, $32,999. 1 subtract 0.08 to the t, okay? 0.08, not 0.8. That'd be 80%, okay? And then to get 10 years, I'm just going to put my 10 in for there, in for t. I'll go 32,999. I'll go 1 minus 0.08 to the 10 power. Gotta have a calculator, right? Gotta have a calculator. 32,999. 1 subtract 0.08 to the power of 10. Let's see what this car is worth in 10 years. About 14,000. 14,334 and 38 cents. There you go. How am I doing? Turn the page when you're ready. Okay, turn the page. Oh, sorry, my bad. Take a picture of it? That'll work. Okay, you got it? Okay, now, geometric formula, okay? Geometric, this is our A1 R n minus 1 power, okay? I did not put this on the test because we didn't talk much about the geometric, okay? I put the arithmetic one is, geometric's not. A1 is 144, so I got AN equals 144, that's my first term, right? What's my multiplier? I don't know, but hey, Mars, you remember how we found the multiplier? What did we do to find the multiplier? Remember what we did? We took the second one.
Oh, you did the second number divided by the first number and you base and click correct. But
Yep, and I told you it always, right? Always, so same thing, 96 divided by 144. 2/3, 0.6666666, 2/3, right? So that's my 2/3 to the n minus 1 power. Okay, so there's my formula. And then if I want the 8th term, I'll just plug in 8. I'll go A of 8 equals 144, 2/3 to the 8 minus 1 power, right? And I'll just do the same thing. I'll go 144 times 2/3 to the power of 8 minus 1, right? Which is basically 7, but you know, all right, whatever. Okay, about 8.4. About 8.4. Do that term, okay? How am I doing? Okay. Am I going too fast? So number 8. So a number of bacteria, they're growing. What's the rate? Now, I think it's tripling, but again, if we don't know what the rate is, how can we find the rate? How can you find the rate? Second one divided by the first one, right? If you don't know how to find the rate, you know it's exponential. It's always second one, which is 3. If you can't figure out what's going on, always divide the second one by the first one, okay? So it is 3. So I'm going to have an equation. Y equals 1.2 times 3 to the t power, okay? Complete the chart. Oh, I can do that. That's easy. I can complete this chart. 10.8 times 3, that's 32.4 times 3, 97.2 times 3, 291.6. Okay, there, I completed my chart. I have my equation, right? 1 day is 24 hours, right? 1 day is 24 hours. Because it's in terms of hours, right? So I'm going to take my 24 and put my 24 right there. So I'm going to go really 1.2 times 3 to the 24th power. Clear. 1.2 times 3 to the 24th power. And I get, in terms of thousands, I get 3.389 thousands, or I could just move the decimal. Bacteria. Right? And number 9, tell me when you're ready for number 9. Okay? So, this is 1/2 cubed. 8 is 2 to the 3rd power. This is like an extra credit problem. I like it. 16 is 2 to the 4th power. Okay. We will talk about negative exponents more in geometry, but I've introduced them. We've talked about it briefly. We'll talk about a lot, but we'll talk about a lot more in geometry. So negative exponents are in the wrong place. When I move them, remember this? I move a negative exponent, it makes it negative, okay? So I take a negative exponent, make it, okay, so I'm going to move this up and make it to the negative 3, okay? It's like an extra credit problem. It's beyond what we do in Algebra 1. So that's 2 to the negative 3 power. Okay, and then at this point you do have the same bases. And then I'm going to solve it, and I'll have let's see, a negative 3x minus 9 equals 8x plus 4, and I'm almost done, right? Plus 3x plus 3x. Negative 9 equals 11x plus 4 minus 4 minus 4. Negative 13 equals 11x. Divide by 11. So negative 13/11 is a really ugly looking number, but if I'm going to keep it like a fraction, I'm okay with it, okay? All right, so that's about as hard as you'd see tomorrow, or not tomorrow, but Wednesday, and that'd be it, okay? In fact, I don't even think I put anything that hard on the test. I did not. Did not put anything that hard on there. Okay, so